What's up YouTube? My name is Johnny Bannon with Trepid Technologies, and today is our last video in our EIGRP series. So click the link below and let's get started. So today we'll be going over unequal load balancing in EIGRP. This is the only interior gateway protocol that actually does unequal load balancing, and this can be done from any router. There's no special router like an OSPF. Talking about ABRs and ASPRs, right guys? But today, instead of going through our Confluence how-to page by the numbers, I'm actually going to make a new diagram, or new network diagram on GNS3 and walk you through it step by step. So no VS Code today, no Git, none of that guys, just straight command line, just to actually show you the technology, to actually get into the variance command and the load balancing that we're going to do on EIGRP. So let's do it. So we don't need this today, but if you want to go in and just read about unequal load balancing, how to configure the variance command as a reference, please use this. But today, we are going to use this network diagram, guys. So I got 4 routers here, right? So what are we doing with these 4 routers? So Phoenix router right here is going to have 2 different ways to get to this subnet, and this subnet. And we're actually going to tweak the metric by making these networks right here less than these. So in EIGRP, as these routes get advertised at each hop, there's going to be a reported distance in K1, right? Or excuse me, there's going to be a bandwidth, that's the K1 value, that's going to be added to the metric calculation, and that's going to be reported every step of the way to its neighbors as these routes reach the Phoenix router. So essentially what we're going to have here is that to this route, and to this route, and to this route, Phoenix is going to have 2 different ways. One is going to be preferred, that's going to be this side, and this one's not going to be preferred, and you won't see it in the routing table because only the best routes get put in the routing table. What we call that in EIGRP is a successor route, and then the backup route is the feasible successor. And the feasible successor is only a feasible successor if it meets the feasibility condition. So what does that mean? On our successor route right here, if the reported distance from here to here of, let's say, this route is less than the feasible distance of this route of 10.2.2 being advertised from Houston router, then it'll be the feasible successor. If it doesn't meet this condition, then it can't be put as a feasible successor in the topology table. Now I know that may not seem like a lot, like it makes no sense, right? But please refer to our Confluence page. I have on the actual EIGRP how-to space or page, I have a whole PowerPoint made out that explains the feasibility condition. Please use other references, right? I use CBT Nuggets, IME to train and study. Cisco Pressbooks can be helpful with just tweaking that knowledge to make sure you actually understand it. But today is going to be all about configuration. So let's do it. So I'm going to start these routers. Now I'm going to start from the right to the left. So the Phoenix router is the one I want to show you guys how to do unequal load balancing. So we'll configure it last. We're going to use named EIGRP, and let's start on our Honolulu router over here. Alright, so I'm not going to put a base configuration like you've seen me do in other routers. I'm just going to get this guy working. Let it load for a little bit. And I'm using viral routers, guys, in case you were curious what iOS image I have. I'll give it a host name just so we can be pretty clear here and not get all confused. Let's look at our network diagram. Alright, first thing I'm going to do is I'm going to set up EIGRP. We're using name mode. Again, I'm going to go through this kind of quick because what I want to show you guys today is unequal load balancing. All this other stuff we should have learned in the past videos, right? So now we're going to go into get 0, set the bandwidth to 384 kilobits. Show you that bandwidth in kilobits. Alright, that's good. 384 is how we manually change it. Let's give it an IP address. The subnet we're using is 10.2.2.0 with a /24. No shut. Now let's get to our other interface. Set the bandwidth first. 512 kilobits. And I'm not doing this in any order. You can put the IP address first if that's how you want to go about it. No shut. Then we have a loopback that I made over here. This guy right here. Loopback 0, we'll give it an IP address /32. We don't need a no shut loopbacks, right? They're automatically on. Great. Now let's go into Houston and Seattle. Console in. We'll start with the Houston router, guys. Let's do some configuration. So on both of its interfaces, we're going to give them the bandwidth of 512. So first host name, they're going to go interface range gig 00 through gig 01. We can set the bandwidth like this. Then go back into the individual interfaces, give an IP address. IP address 10.3.2/24, no shut. We'll go into gig 00, IP address 10.0.0.1/24, no shut. Alright, let me slow down for a second. So all we did right now is change the bandwidth of gig 01 and 00 to 512. And we're doing this, right, to make the routes coming from Houston look more preferred than the routes coming from the Seattle router, okay? That's why we're changing the bandwidth. And now, we're going to set up named EIGRP. Now you may be wondering, hey, wouldn't it be faster just to do regular EIGRP if we're trying to get down to business and just do unequal load balancing? And you would be correct, but if you remember from our past videos, the named EIGRP actually uses something called wide metrics. And I want all the metrics as it goes by each hop to be the same. Alright guys, so now we're on the Seattle router, and we're going to do the same thing we did on the Houston router. Let's just set the bandwidth now, since they're going to be the same. Gig 00 and 01, 384. Then we'll go into the individual interfaces and give them an IP address and no shut. Really simple, really easy, guys. We're just trying to get the actual load balancing, right? EIGRP4, unicast time system 1, network, default. Okay. So if you've been watching these syslog messages, we have EIGRP set up between Seattle, Houston, and Honolulu. So now, what we came here for, the Phoenix router. Put this right here. Expand it a little. Give it a host name real quick, Phoenix. Go into its interfaces, change the bandwidth. We actually don't have to do this since this router will actually be giving the reported distance. But just for clarity, I'm going to do it. But it would still work even if we didn't change the bandwidth on Phoenix's interfaces. Gig 00, the address 10.0.0.2. Let's change the bandwidth as well. Got the no shut gig 1. Now EIGRP for unicast time system 1. Alright, now we're going to see our neighbors come up. And let's go look at a few things first, guys. Right, we just did that super quick. So now let's take our time and look at our routing table and our EIGRP topology table. So we should be getting EIGRP routes for this network, and this network. Okay, guys? We're not going to see these as EIGRP routes. We'll see them as local and connected. Let's do show IP route EIGRP. Okay. So as you can see here, the 10.3.3 network we're learning via here. The 10.2.2 network we're learning via this one. And that makes sense, right? Because even though this bandwidth is more, if you do it by hop count, the metric will be better, okay? And then this one, this loopback, we're learning it via 10.0.0.1 because we're going to send that route out both interfaces, and this router is going to see that going this way is a better metric because of the higher bandwidth. So now let's look at our EIGRP topology table to see if we have any feasible successors. So these would be considered our successors right here. And this is their feasible distance, their metric, right? Their distance to get to this route right here. And this is the next hop, right? So our topology table. Okay. So we don't see any feasible successors. So what are we going to do? Let's go to all links right here, guys. This will show us the entire topology table. So what we can see here is that we don't have feasible successors for these routes because this doesn't meet the feasibility condition. Okay, guys? So let's go in and do some changes. So let's say I want to do this. I want to make unequal load balancing for this route right here. So what we need to do is use the variance command, okay? So what we're going to do is we're going to take this feasible distance and divide it by this feasible distance, okay? So let's get our calculators out. I'll use my calculator on my actual computer. Just grab it real quick. Alright. So this is our successor route. As we can see here, one successor. So we're going to take its feasible distance, put it in our calculator, then we're going to divide it by this one's feasible distance. We get 1. Okay. So now, this is weird. It should be 512. So let's go make sure that I actually did this correctly. Let's go back to the Houston router and make sure that its bandwidths are 512. Yep, we put it at 512. Show interfaces. 512. 512, those ones are down. Let's do it to Phoenix. I think gig 00 is 512. And that way is 384. Let's do this, guys. Let's clear our neighbors and let's see if we get any changes. Because we shouldn't see that, right? What we're looking at here is that from 10.1.1.1, our bandwidth is 384. That makes sense, our minimum bandwidth. But to 10.0.0.1 to the Houston router, our minimum bandwidth should be 512. So let's see if that changed anything. We'll go back and look at it. Still doing it. Okay. Let's try our variance command. Either way, again guys, so in GNS3 sometimes emulation can be just like this. Not doing what we told the router to do. On an actual Cisco router, we would not have this issue. Okay? So let's just try giving the variance of 1 in EIGRP. Let's see what we get. So if this doesn't work, we'll blame it on emulation for now, right? But this is the way that you would do unequal load balancing. If you go on any how-to, I'll show you one that I used for this. It'll show you this is exactly how you do load balancing. So let's look at our routing table now. Still nothing. Our topology table. Because usually you can only do variance on routes that are feasible successors. If you don't have any, then you can't do unequal cost load balancing. So it's weird that even if we look at these numbers, it does meet, I believe it does meet the feasibility condition, but for some reason we're not putting it in our routes. So let's just try it with 1.1.1. Well, no, because there's no feasible successors, so this won't work. Let's try this. Let's try reloading the Phoenix router. We'll save it. We'll see if that fixes our issue, guys. So when you reload from the command line here, it sometimes doesn't work. So we'll do it. Stop. Start. And we'll see what we get. Because we should see the minimum bandwidth is 512. We were seeing 384. So that's no good. See if it saved its config. I hope it did. And again, guys, this video is still going to go up online even if this isn't working for us. Because I want to show you what can happen at your home labs, right? Not everything's perfect in life. So this could happen to you just like it's happening to us in this video. And once we hit the 20-minute mark, I'll cut it off. But I just want to see one more time to see if we can actually get this working. So there's our neighborship. Let's look at our topology table. Still nothing. Let's see if we're still getting that weird bandwidth. We'll do 1.1.1. We want to look at the topology table. Still, let's see here. So now we're getting this. So let's see if we can try our variance this way, like we have been doing. Into the calculator, divided by feasible distance here. Gotta copy that, guys, of course. So this is why it doesn't work unless you have a feasible successor, because it has to meet that feasibility condition, because the variance command cannot be less than 1. So let's try this, guys. Let's try going into the Seattle router and changing port or gig 00 to a higher bandwidth. We're the same. 12. Go back to the Phoenix router. If this doesn't work, then we'll just call it a day. At least you got shown the variance command and what it can do. We'll clear EIGRP neighbors. Get a reset. And then let's look at our topology table. Okay, so now we're seeing a feasible successor at topology table. So let's look at our routing table. Still only one route to there. So let's go in to EIGRP and plug in a variance of 2 and see if that works for us. Variance 2. Show IP route, EIGRP. Oh, now we're cooking, guys. We go back to our topology table, go to our calculator, you see that this does meet the feasibility condition now. believe it's the same metric, so honestly it could have been GNS3 giving us issues, guys. 0.75 again, but when I did the variant to 2, now we're seeing it. Alright guys, so thank you for coming to this how-to. Sorry if this was a little confusing. Right before this lab I did it exactly how you're seeing it here with no issues, but we got to where we need to go. So if we do this again, show IP topology, 1.1.1, 255, 255, 255, we can actually see, where is it? Actually, let's do show IP route. Share count is 4, share count is 3. So that means we have a 3 to 4 ratio here. So that means we are doing unequal load balancing. So if we do trace route, look at that. One link here, one link here as the next hop. So as you can see, we are doing unequal load balancing, guys. So that's good. That's good news. Alright. So I know that was a little rough, but we got through it, guys. So from everyone here at Tripit Technologies, I want to thank you for viewing. Remember to keep learning every single day. Thank you.